In the previous video, we got introduced to the versatile nature of carbon. Can you tell me why it is capable of forming so many bonds with so many elements around? To know this, let's have a look at the atomic structure of carbon first. Does the atom look somewhat like this? Yes. The electronic configuration of carbon is 2,4. That means it can either donate or accept 4 electrons to achieve stable state. However, it's not as easy as it seems. This is because donating the 4 electrons will mean that the atom is now left with only 2 electrons. But the number of protons still remain the same, right? That means the atom will gain positive charge and will still be unstable. Similarly, accepting 4 electrons will also lead to a situation where the carbon atom becomes negatively charged. Thus, both the situations would lead to instability of the carbon atom. So the option that carbon adopts is to share electrons. Sharing in carbon can take place up to 4 electrons. That means carbon can share all its valence electrons with any other atom. We know that such sharing of electrons leads to a special type of bond formation called the covalent bond. So to understand carbon chemistry, we need to understand covalent bonds first. How can we define a covalent bond, by the way? In simple words, it's the bond formed between atoms by the sharing of electrons. Now the next question that pops up in our mind is how many electrons need to be shared to form a covalent bond? Is it 1 electron or a pair? Or more than a pair? Can you guess? Let me help you with the answer. When we say sharing, it means that both the atoms need to contribute for the bond formation, right? It indicates that each atom will give at least 1 electron from its valence shell. Does that tell us that a covalent bond will involve minimum of 1 pair of electrons? Yes, a covalent bond needs at least 2 electrons or simply 1 pair of electrons. Such a type of covalent bond where 1 pair of electrons is shared between the atoms is called a single covalent bond. It is denoted by drawing a single line between the 2 atoms. A simple example that explains this type is the formation of a chlorine molecule. How do you think this molecule was formed? We know that chlorine has 7 electrons in its outermost shell. That means only 1 electron is needed by it to complete the octet. Now here's another chlorine atom which again has 7 electrons in its outermost shell. Both of them want 1 electron each. And that is why we find 2 chlorine atoms coming together and forming a bond by sharing 1 electron pair. Now if we look at this orbit individually, it has 8 electrons. And this orbit too has 8 electrons. Stability achieved for the chlorine molecules. This was an example of a single covalent bond. So do all atoms form covalent bonds by sharing a single pair of electrons? Think for a moment. We know that oxygen is in the diatomic state. That means one oxygen atom forms a bond with other oxygen atom to form a stable molecule. Do you know how many electrons are shared in this bond? What do you notice? There are 4 electrons shared. That means both the oxygen atoms contribute 2 electrons each, thus giving 2 pairs of electrons in the bond formation. So is this not an example of covalent bond? Well, it is. But covalent bond has 1 pair of electrons being shared, right? Don't forget, it is a minimum of 1 pair that's needed for formation of the covalent bond. That means this case is also an example of a covalent bond. Such a covalent bond which involves 2 pairs of electrons getting shared is called a double covalent bond. It is represented by 2 lines written between the 2 atoms. Just like this as seen in case of oxygen. Now on the similar lines, can you give me an example where more than 2 pairs of electrons are shared between the atoms? Wait a second, are we trying to say that a triple covalent bond also exists between the atoms? Absolutely. And the best example to study this is the case of nitrogen. We always find a nitrogen molecule written like this. Needless to say that the 2 nitrogen atoms share a triple covalent bond. That means 3 pairs of electrons or simply 6 electrons are shared between the atoms. This helps both the atoms attain the stable state. Now tell me one thing, which type of covalent interaction does carbon prefer? Does it opt for a single or a double or a triple covalent bond? Astonishingly, carbon has the ability to form all these types of covalent bonds with different elements. Yes, it can have any of these covalent interactions with atoms of other elements or even with other carbon atoms for that matter. In the next video, let's have a look at how exactly carbon forms bonds.